Jetaji Education introduces Speaking Chemistry for greater understanding and improve basics and fundamentals. Hello students, today
we will discuss mole concept, or what is a mole. Before we discuss mole concept, let's consider Avogadro's number. Let's imagine how big this number is, means, like 10 is more than 1, 100 is more than 10. When we compare with day-to-day activities, these numbers are small. But what about Avogadro's number? How big this number is? Let's compare. Suppose you have Avogadro's number of rupees, and you can live infinity years. If you spend rupees 1 crore per second, then how long will you take to spend all the money? Let me give you options. A. Less than a day. B. Less than 100 years. C. Less than 100 crore years. D. None. Right. Okay. Let me calculate. You spend rupees 1 crore in 1 second. Avogadro's number of rupees will be spent in nearly 200 crore years. Therefore, the answer is none. You will take nearly 200 crore years to spend all the money even if you spend at the rate of rupees 1 crore per second. Hence, Avogadro's number is a huge number. But this many number of hydrogen atoms weigh only 1.0079 gram. Only 1.0079 gram. Imagine how small hydrogen atoms are. If anybody asks you to buy 100 gram of potato, you will say no, I won't go, what the shopkeeper will think. Means 100 gram is nothing for you. Imagine the size of atoms and molecules. Avogadro's numbers of hydrogen atoms weigh only 1.0079 gram. Now if you go to a grocery shop and ask for 100 number of rice grains, what he or she will say? He will say go and ask again whether it is 100 gram or 1 kilogram rice. See. The substances, which can be counted under naked eye, are still uncountable, but what about those, which you cannot see clearly, even under ultra microscope? How can you count them? The mass of the atoms and molecules are so less, you cannot use gram as a unit, or kg as a unit, as these are used for appreciable amount of substances. Like you don't say this many crores gram of mango is transported, rather you use quintal or ton unit, that is, this many quintal or ton of mango. Similarly, for a very small amount, you cannot use gram or kg. Similar is the case for volumes of atoms and molecules. For using ml or liter as unit of volume is absurd. Conversion does not mean you will use it everywhere. Like suppose you have 10 paisa, you can't say I have 0.000000001 crore rupees. As the amount is less, you use a unit, accordingly as paisa. To overcome these difficulties, a term called mole is introduced. Mole can be defined as: it is a chemical unit, which is used to express the amount of microscopic or subatomic particles, like atoms, molecules, ions, electrons, protons, etc. As per IUPAC, mole is represented as mole. Amount can be number, mass, volume, etc. What amount of banana you bought? Answer: 10 number of bananas. What amount of milk is required? Answer: maybe 1 liter. What amount of rice you bought? Answer: maybe 2 kilograms. If I ask you, 1 mole of cow means how many cows? You will say Avogadro's number of cows. No, it's wrong. Cow is not a microscopic particle. Now, suppose you go to a grocery or vegetable shop and ask, give me 1 kg. What? he or she will give you. Do you think kg has no meaning? Yes, kg is the unit of mass. It will be meaningful when kg is operated on something, like 1 kg rice, 1 kg brinjal, etc. Similarly, mole is a chemical unit. Until and unless it is operated on particles, it has no use. Let me use it on atoms. 1 mole of atoms contain Avogadro's number of atoms. Occupies 22.7 liters at STP or NTP, applicable only for gaseous substances. Weighs 1 gram atomic mass, GAM, is equal to atomic weight. Note, 1 mole of atoms also known as 1 gram atom. You can use this for molecules, ions, etc. also. Now, what do you mean by gas, vapor and gaseous substance? Gas, those substances, which are in gaseous state, under ordinary conditions of temperature and pressure, are called gases. Example, oxygen, hydrogen, nitrogen etc. Vapors, those substances, which are in gaseous state, under a suitable condition but ordinarily, exist in liquids or solids are called vapors. Example, water vapor, ice vapors, ice sublimes at -10 degrees Celsius. Gaseous state, the state of the substances, in which interparticle distances are high, interparticle forces are feeble, is called gaseous state. That is, gaseous is a state, whereas gas and vapors are substances in gaseous state. Units of pressure. 1 atmospheric pressure is equal to 1 atm, is equal to 760 mm of mercury, is equal to 760 torr, is equal to 76 centimeters of mercury, is equal to 1.01325 bar, is equal to 1.01325 into 10 to the power 5 Pascal. 1 mm of mercury is equal to 1 torr, and 1 bar is equal to 10 to the power 5 Pascal. Remember, SI unit of pressure is Pascal. Now answer a few questions. Exercises. 1. Time 10 minutes. A. 0.02 gram of helium atoms occupies how many ml at STP? B. 3.011 into 10 to the power 20 on nitrogen atoms, how many moles? C. 0.227 milliliters of neon atoms at STP contains how many number of atoms? D. 0.01 gram atom of helium occupies how many liter at STP? E. 6.023 into 10 to the power 22 molecules of water occupies how many ml at STP? F. How many moles of atoms are present in the solution in a container when you add 1.8 gram of glucose and 0.45 gram of water? G. A cup made up of fructose is dissolved in 180 milliliters of water to form a 24 gram molecule of solution. Find the number of carbon atoms present in the solution.
Thank you for watching. If you found this video is helpful, please like, comment, share, and subscribe to get series of similar videos.